Now, before we go any farther, I want to address this issue right here. We got row 1 for level 1, row 2 for level 2. We come back over here, and we notice that these 4 right here, or these 2 here, and these 6 right here, are in the 4th level and the 4th row. But these 10 right here belong to the 3rd level. Okay. Okay. Now, so this is level 3 is found in row 3 and row 4. Both. Okay, so let's take a look at one more time to make sure we understand that. This is found in row 4. These 6 are found in row 3. So we got 2 sections in row 3 and 1 section in row 4, but they're all considered 3rd level electrons. Okay? Now, we go to level 4. And we just take a look at the mathematics of this, and then we'll take a look at where it's located on the periodic table. You see 2 electrons, plus 6 electrons, plus 10 electrons. And as we said, these numbers keep going up by 4. At every level, you're going to get a new series of electrons added onto it. And that will give us 14 electrons for a total of 32 electrons. Well, we know where the 2 is. I've got to stop doing that. The 2 is these first 2 columns right here, except for the first row, which are these 2 only found in the first row or first level. But all the others are found in this grouping of 2 on the left-hand side. Then, this 6 here, this 6 here, that 6 there, are found in this block of 6 right here. There's the first 6, there's the second 6, there's the third 6. So that's level 2, level 3, level 4 of those 6 electrons. Then, 10 and 10 is that block in the middle. So we take a look at that. We got these 10 here are the level 3 electrons. These 10 right here are the level 4 electrons. Now, what happens next with the 14? We know it's 14. If your periodic chart has a gap like mine has here, then you're going to take these 2 right here to snip it off and put it right in there. Just momentarily. If you don't have a gap there, ignore the snipping off. This has already been taken care of. Okay? Once you have these filled in, or once you already realize that it's already filled in, count the number of columns after the lanthanum and the actinium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Now, why did they just go ahead and put it in there? Well, the size of the paper will be like this. It's too big. So they stuck them down there so it will fit on the piece of paper. That's the only reason. They actually, these electrons right here actually belong in the 6th row. These electrons right here actually belong in the 7th row. You've got to remember that. And it helps to remember 56, 57, 58, blah, 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 71, 72, 73, same for this. These 14 right here represent the next batch of 14 electrons in that addition that we have there. Now, I will tell you, as of right now, this is as far as we go with the number of electrons, new kind of electrons, new quantity of electrons, I should say, that goes into the formation. We are this close from coming up with the next kind. And now we can hypothesize in our minds how many electrons we expect to be in that next batch. Well, you add 4 more, you should see 18 more electrons. But more importantly, let's go back to the rows for level 4. So let's just take a look at this. We got 2 there, we got 2 and 6 there, we got 2, 6, and 10 here. The 4th row, or the 4th level rather, we got 2, 6, 10, and 14 right here in the 6th row. So we got, so that means we got 4th row for these, 5th row for these, 4th row for these, and 6th row for these. So our electrons are found in 3 rows, and the first row is split up into 3 parts. So that means we're going to find it in row 4, row 5, and row 6. So we'll put that right here. So row 4, row 5, and row 6. Right there. Okay? Now, here's where it gets really important to help predict what's going to happen, and it becomes a little easier as we go through what we're going to do in the next 2 days, the next 2 videos. In this particular case right here, because level 3 electrons, those 10 in the middle, didn't show up to the 4th row, then we say those middle 10 are 1 row late. They should have been found in the 3rd row. They didn't show up until the 4th row, so they appear 1 row late. Okay? The bottom 14, that's these down here, the middle 10, is this blue column. We have our blue sets of columns right here. This light blue and light green here are actually the 14 minus a couple of them that belong up here in that little gap. These are 4th level electrons found in the 6th row. So that means, of course, that the bottom 14 are 2 rows late. So the shape is designed for a specific purpose. It isn't something random that they found all these gaps and oh my goodness, this doesn't fit there. It actually started out like that. But this appeared, they didn't even know what an electron was until like 50 years after the first periodic table was submitted as a possibility. They didn't know electrons were, they didn't know protons, they didn't know neutrons, they barely knew what atoms were. Atoms were found in 1800. This is like 30, 40 years after that. Then this comes along. Bohr was around in about 1900, 1905, somewhere around there. And we already knew what the electron was, and we had an idea about the proton. We didn't know anything about neutrons. Protons were about to be discovered by Ernest Rutherford, and about the same time Bohr was dealing with this thing here. After, I think it was just after Rutherford found the neutron with his gold foil experiment. And if you want to see how that worked, that's kind of interesting to watch. But regardless, that leads us up then to looking at a periodic chart and predicting what the highest energy electron is, where it's located. So let's do that. Let's do 4 examples of that so you can see how that works. First example, in what level is the highest energy electron in silver? All right, so let's take a look at that. Let's find silver on the periodic table. There it is right there, Ag. Right there. It's in that middle 10. What row is it found in? It's found in the 5th row. But we know that those middle 10 are found one row late. So this is not a fifth energy electron. This is a fourth energy electron because it shows up one row late. And so it's a level 4 electron. Example. What level is the highest energy electron in xenon? Xenon, such a cool name. Xenon is all the way over here. Now it's in the same row as silver. But silver's in the middle, this is in the right 6. Now remember, elements in the left 2 and the right 6 are not late. The row is the same as the level. So if xenon is found in row number 1, 2, 3, 4, 5, then we would expect this to be a fifth level electron. And it's in the right six. Oh my goodness, I did that wrong. I'm supposed to be level 5. I'll have to fix that. Let me go back and make sure I counted right. I might have counted wrong. Let's see. No, that's 5. I went too far with the radon. So that's so that is a level 5, not level 6. And I'll fix that in the script before you get it. But it's wrong up here, but I will fix that. Next one, what level is the highest energy electron in uranium? Okay, let's see if I got that right. Holy cow. So, uranium's down here, element number 92. That's the stuff that's heating up the power plant down the road. Alright? So, this is in that middle or that bottom group of 14, which means it's how many rows late? Dos. So we need to figure out what row this is found in. Well, this is in the 7th row. So 7 minus 2 is 5. So that means that this is the highest energy electron in uranium is a 5th level electron. Now let's see if I actually did it right. Level 5. Yay me. Okay, last. And what level is the highest energy electron in rubidium? Rubidium. All right, let's find rubidium here. Rubidium is that left 2 right here. Oh, look, column number 5 again. I have a thing for 5. So, because they are not late, that means it's going to be a 5th level electron. And I'm sure I got that right because I kind of remember typing that. And lo and behold, I did. So, your job for the practice problems is to give the energy level the highest energy electron in each of those elements. Representing one atom of each of those elements, where is the highest energy electron for that?